Today we're going to talk about solving quadratic equations. A quadratic equation is an equation equivalent to one of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. To solve a quadratic equation, we get it in the form above and see if it will factor. For example, if we take x squared is equal to 5x minus 6, we get the form above by subtracting 5x and adding 6 to both sides to get a 0 on the right-hand side. Once it's in this form, we factor by our chosen method. After factoring, we see that we have x minus 3 times x minus 2 is equal to 0. We can then use the zero factor property and set each factor equal to 0 and solve. Our result is x minus 3 equals 0 and x minus 2 equals 0, giving us x equals 3 and x equals 2. Remember that the standard form of a quadratic equation was ax squared plus bx plus c equals 0. In this form, we could have the case where b is equal to 0. If this were the case, our equation would look much more like ax squared plus c equals 0. When this is the case, we can solve using the square root property. For example, if we take 2x squared minus 6 equals 0, we can get the x squared alone by adding 6 to both sides and then dividing both sides by 2. Our resulting equation looks like x squared equals 3. Now if we take the square root of both sides and remember that we must consider both the positive and negative root by putting a plus or minus on the right-hand side. We're left with x equals plus or minus the square root of 3. So let's check this and see if it works. If we plug square root of 3 in everywhere we saw an x into our original equation, the result is 6 minus 6 equals 0, which does check. If we put negative square root of 3 in everywhere we saw an x, it also gives us a result of 6 minus 6 equals 0, which is correct. So what if in standard form our c is equal to 0, meaning that we don't have a constant? We could factor by pulling an x out of each term, or more commonly a GCF. Let's look at 2x squared minus 3x equals 0. If we factor out the common x, we have x times 2x minus 3 equals 0, and use the null factor law to set each factor equal to 0 and solve. So x is equal to 0, or 2x minus 3 is equal to 0. Our results are x equals 0 or x equals 3 halves. If you put either of these values in for x in the original equation, you can see that it makes a true statement. What we're going to have to do if we have a non-zero values for a, b, and c, but can't factor on the left-hand side. For example, x squared plus 6x plus 3 equals 0 is prime. I'm not able to factor the left-hand side. So we could possibly complete the square and then apply the square root method. In order to do this, we first get the constant term on the other side by subtracting 3 from both sides. The result is x squared plus 6x equals negative 3. We're now going to add a number to the left side so that it will factor into a perfect square trinomial. This means that it will factor into two identical factors. If we add a number to one side of the equation, we must always add it to the other side to keep the equation true. So let's add 9. Right now we see that it works, and then we'll look at how to find it. We combine like terms on the right-hand side, and we're left with x squared plus 6x plus 9 equals 6. So now let's factor the left-hand side. We can see that because it's a perfect square trinomial, we get x plus 3 times x plus 3 equals 6. Two identical factors. We can also write this as x plus 3 quantity squared equal to 6. Now we'll get rid of the square by taking the square root of both sides. Don't forget the plus or minus. We subtract 3 from both sides to isolate our x. And the answers in exact form are x equals negative 3 plus or minus the square root of 6. We can put them into the calculator to get the two approximate answers. Okay, so this works to solve the equation, but how did we know to add 9 to both sides? We wanted the left-hand side to factor into two identical factors. When you FOIL, the outer terms and the inner terms need to be identical and need to add up to 6x. In this case, the 3x plus 3x results in my 6x. The last term in the original trinomial will then be the middle term's coefficient divided by 2 and squared, since the last term times the last term will be 3 times 3, or 3 squared. So to complete the square, the number to add to both sides is the middle term's coefficient, or b value, divided by 2 and then squared. Let's solve another one by completing the square. Let's try 2x squared minus 16x plus 2 equals 0. To complete the square, we want the coefficient of the x squared term to be 1. This is required for completing the square to work. So let's divide every single term, including that 0 on the right-hand side, by 2, or our a value. The result is x squared minus 8x plus 1 equals 0. Now, since it doesn't factor, we can take that constant to the other side and be ready to complete the square. So what do we add to both sides? We take our b value, our middle term's coefficient, which was negative 8, divide it by 2, and then square it. So our result is 16. That's what's going to be added to both sides. We now factor the left-hand side, which we've made into a perfect square trinomial. And we get x minus 4 times x minus 4. Notice that the number inside of the two identical factors is that b value divided by 2 before I squared it. Once we've made it x minus 4 quantity squared on the left-hand side, we combine like terms on the right-hand side to get a 15. We take the square root of both sides and remember the plus or minus. What we're left with is x minus 4 equals plus or minus the square root of 15. Now we're adding 4 to both sides because, again, we're trying to isolate the x. And our result is x equals 4 plus or minus square root of 15. By completing the square on a general quadratic equation in the standard form, which was, remember, the ax squared plus bx plus c equals 0, we came up with what is called the quadratic formula. Some of you may remember that there was a song that went along with that, but we can talk about that later. The quadratic formula that comes from completing the square is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And make sure that that fraction bar goes across the entire right-hand side. This formula can be used to solve any quadratic equation, whether it factors or not. If it factors, it's generally easier to factor, but this formula would give you the solutions as well. Sometimes if an equation is difficult to factor, for instance, if my a is greater than 1, it's less time consuming to go straight for the formula and not bother trying with AC method or the less efficient guess and check method. So let's try one. We solved x squared plus 6x plus 3 equals 0 by completing the square. Let's try using the quadratic formula and see if our answers match. So as you can see, my a value is going to be 1, my b value is 6, and my c value is 3. Remember that we only use the coefficients and that constant. We don't want any variables inside of our quadratic formula. So if we replace a, b, and c everywhere we see the corresponding variables in the formula, we end up with negative 6 plus or minus 6 squared minus 4 times 1 times 3, underneath that square root, all over 2 times 1. Don't make a mistake with order of operations here. Let's do the power and the multiplying first. So our next step yields negative 6 plus or minus the square root of 36 minus 12 all over 2. From here, we continue to break this equation down and simplify as far as we can possibly go. So from negative 6 plus or minus square root of 24 over 2, we're able to break apart the square root of 24 into 4 times 6, with 4 being the perfect square. If we take the square root of 4 out and leave the 6 inside, we get negative 6 plus or minus 2 square root of 6 all over 2. Now, there's a 2 in common in the terms of the numerator, or we can call it a GCF. If we factor out that 2, then we can cancel the 2 in the top with the 2 in the denominator, and our result is negative 3 plus or minus square root of 6. These are the solutions we got when we completed the square on this problem.